In this presentation, we're going to look at hypothesis testing, and in particular, what we're going to look at is two important aspects of hypothesis testing: the null hypothesis and the alternative hypothesis. Now, hypothesis testing can be used to determine whether or not a statement about a particular value of a population parameter should or should not be rejected. That is to say, should we believe it or should we disregard it? The null hypothesis, which is denoted by H0, is a tentative assumption. Tentative is like we'll make an initial statement about, make an initial assumption, but we might sort of change that assumption later on. Is a tentative assumption about a population parameter. Now, just a quick remark: population parameters, for example, mu or pi. Population mean, population proportion. Those are the population parameters. Just as a quick remark on those. So we actually make a statement about some population parameter. The alternative hypothesis, which is denoted HA, is the opposite of what is stated in the null hypothesis. Now that's actually very important. Is the opposite of what is stated in the null hypothesis. That's actually quite an important statement. So the alternative hypothesis is what the some analysis is what you're trying to establish, what you're trying to prove or not prove. It's what you're trying to sort of see, is this a viable assumption? So the research hypothesis should be expressed as the alternative hypothesis. So if you're conducting a study and you're looking to sort of check if some conclusion from the study is realistic or something that should be accepted, you would actually sort of express it as the alternative hypothesis. And remember, the alternative hypothesis is the opposite of the null hypothesis. So in that case, the research hypothesis, the null hypothesis will sort of directly contradict what the research hypothesis is. Now, the conclusion of the research, if the conclusion that the research hypothesis is true comes from the sample, or false comes from the sample, and so we were basing all this on the sample data. So let me just read that again. The conclusion that the research hypothesis is true comes from the sample data that contradicts the null hypothesis. Okay. Otherwise, if you could look at it the other way around, if it's false, the sample data does not contradict the null hypothesis. So, for example, if we're testing the validity of a claim, suppose we're dealing with manufacturers, and for example, cornflakes packets, we might sort of make a statement that the weight of 1 kilogram of cornflakes is 1 kilogram. So you might check that. Testing the validity of a claim. Manufacturers' claims are usually given the benefit of doubt and stated as the null hypothesis. And the conclusion that the claim is false comes from sample data that will contradict the null hypothesis. So for argument's sake, if you were to weigh 100 boxes of cornflakes and find that most of them are under 1 kilo, there you go. That's how you might go about it. Now, moving on, testing in decision-making situations. So a decision maker might have to choose between two courses of action. One is associated with the null hypothesis, and the other is associated with the alternative hypothesis. So, for example, if you're a shipment of goods, you might accept a shipment of goods from a supplier. It's fine. All the pieces in the shipment are fine, or enough of them are fine. There's only 1 or 2 of them are broken. Or returning the shipment of goods to the suppliers, that there's too many broken parts here, just broken parts here, too many broken parts here. We can't accept it. Back to the supplier. Now, the summary of forms for null and alternative hypothesis about a population mean. Okay, so we can do something here, something similar for the population proportion. So this is a population mean, and we would write that mu. Okay, so we see mu in all of these mathematical expressions down below. Now, the equality part of the hypothesis always appears in the null hypothesis of the hypotheses. So just let's look at we have three pairs of hypotheses. On the top we have the null hypothesis, and below we have the alternative hypothesis. Now just draw your attention to the operators here. So we have greater than or equal to, less than or equal to. So in each of those three operators, the mathematical operator, the relational operator, has an equality component. Greater than or equal to, less than or equal to. So just be mindful of that we would always have the equality component there. Okay. So it's not by accident that they are there. Now, also just remember, they are the null hypothesis and alternative hypothesis express the exact opposite arguments. So the exact opposite to greater than or equal to is less than. So that's why we have less than here. Likewise, we have less than or equal to, then that means we would have a greater than sign to contradict it. And if we have an equal to sign here, that means we have a not equal to sign here. So those are the three ways we could write a hypothesis. Okay. Now let's just read this. In general, a hypothesis test about a value of a population mean mu must take. By the way, this is just some value. Okay. So some particular value. So the average height of people or something like that, of all people. So it's actually some specific value. Must take one of the following three forms, where mu0 is a hypothesized value of the population mean. So just for a quick example, what mu0 is just something like this: mu equals 100, or something like that. It's just a placeholder for a particular value. Now, so those are our three types. Again, the important part there is the equality component is in the null hypothesis, and the null hypothesis and the alternative hypothesis have directly contradictory relational operators, just as I pointed out there. We would have one for the alternative hypothesis, the null hypothesis, and then the alternative hypothesis. Okay, and it's also actually quite common to sort of write a mathematical description. To write a description of both mathematical expressions, just a sort of plain English expression as well. Now, another remark: we have three different types of hypothesis tests there, and the first one is a one-tailed procedure, and we call that the lower tail test. The second one is a one-tailed procedure, and it's the upper tail test. And lastly, we have a two-tailed test. Now, it's quite important to remember all three of these and be able to sort of know, is it one-tailed or two-tailed, and so on. Now, just as sort of rule of thumb, a sort of quick way of remembering, is it one-tailed or two-tailed, what you should do there is just see how many alternatives are offered by the alternative hypothesis. So in this one here, it's just less than, so that's one alternative. Here, it's greater than, it's one alternative. Now, not equal to means less than or greater than, and that's two alternatives. So that's just a sort of quick rule of thumb. So not equal to is the same as less than or greater than. So that's a way of remembering if it's one-tailed or two-tailed. Okay, so I'm going to finish there and prepare for the next presentation.